In this lesson, we are going to be proving slope for 4.02 exit ticket. To start off, let's go ahead and look at this warm-up here. What is the slope of the line passing through the points 2, -5, and 4, 1? You might pause the video yourself and see if you can come up with the answer before I write down the result. So here we can see that this is our first coordinate and this is our x and y, and our second coordinate, so we're using x2, y2. We know that slope is rise over run, and we can write that as the difference of our y coordinates over our x coordinates. It's also important to remember that you are allowed to do y1 minus y2 divided by x1 minus x2 as long as y1 and x1 are always over each other and y2 and x2 are always over each other. It is acceptable. So for me here, I'll go ahead and use my approach with the first one. I'm finding the slope, so I'm going to have 1 minus -5 divided by 4 minus 2. So remember, with negative, we can change that to positive, right? So instead of having negative, it all becomes positive, right? So a lot of times for me, if I just wrote it as 1 minus -5, I recognize that that's negative, so I just make it 1 plus 5. So that gets me 6 over 2, which gives me a slope of 3 over 1. So there is my slope. So you should have arrived at 3 over 1. Today at the end of class, you're going to be able to determine if lines are parallel, perpendicular, or neither. To do this, we're going to talk about slope, finding it and practicing that, learning about equations of lines, learning about parallel, perpendicular, and neither, and we're going to be practicing determining the types of lines and writing equations of lines. So when we look at slope, slope is the ratio of the line's vertical change to its horizontal, which is the rise over the run. The vertical change between any 2 points is the difference of the y coordinates, just as in the warm-up, and the horizontal change is the difference in the x coordinates, just as in the warm-up. So if you know the coordinates of 2 points on a line, the important distinction here is that you can calculate the slope without a graph. You don't need a graph to do that. And so as you see, the formula that we had earlier is right here. And remember, you can write it this way, but also remember that it is perfectly acceptable for you to write it as y1 minus y2 divided by x1 minus x2. The important point here is just remember that as long as you keep y1 over x1 and y2 over x2, then you can write it either way and it's still going to be correct no matter what. Just keep that in mind. So let's look at an example again. Here we have 2 ordered pairs, and it's sometimes helpful to label your x1 and y1 just so that way you understand where you're pulling it from. So for me, my slope m is going to be my y2, which is -3, minus 13, which is my y1, divided by my x2, which is 3, minus -5. Again, I write it this way. Lots of different ways to write that, but we do recognize that that's going to be, in this case, -16 divided by, remember it's minus -5, so it becomes 3 plus 5, so that's 8. And -16 divided by 8 is -2 over 1. So the slope there is going to be -2 over 1. So you might pause the video briefly and come up with the correct response to this particular problem involving the slope between the ordered pairs provided. You should have selected the first option, 3 over 1, as your answer. To get this result, we want to make sure that once again we understand where our x1 and y1, x2 and y2 are coming from. So in this particular case for my slope, I would have -6 minus -3 divided by 3 minus 4. In this case, that's going to get me -6 plus 3 divided by, in this case, -1. That's going to equal -3 divided by -1. Negative divided by negative is positive. So the slope is a positive 3 over 1. That's an example of how you can go about finding the slope between 2 points in the coordinate plane. So we get to the equations of lines. And what's really important about the equations of lines is that if you know a point on a line, and I want to single this out, and a slope of the line, you can actually write its equation. And this is one of our objectives. So we have the 3 forms for linear equations: standard form, slope-intercept form, and point-slope form. I would highly recommend that you either take a screenshot of this or that you at least reference this slide, because it helps describe each of the forms and what is characteristics of those forms and when they're typically used, or otherwise what they have in them. As you can see, slope-intercept and point-slope both use the slope itself in the form, and you can see the slope because it's represented by m. So please keep that in mind. Now, with respect to slope, with respect to what we're seeing here, we're going to go ahead and talk about the equations of lines. To do that specifically, what we want to do is focus on comparing the slopes of 2 lines, and you can determine whether they are parallel, perpendicular, or neither parallel or perpendicular. So comparing the slopes of 2 lines is how we're going to determine whether they're parallel or perpendicular or neither of those. So if you know a point on the line and you know the line is parallel or perpendicular to a line with a known equation, you can determine the equation of the line that your point belongs to. So here's an example of what we want to try to identify. For parallel slope, the thing that you should notice is that they both actually have the exact same slope. So the slopes are the same. Now, you should also recognize that the slope is discernible from the equations and from the visualization, but since we don't necessarily have units written down on the xy plane, it's best to look at the equations. Notice the form they're written in, slope-intercept form. The slope-intercept form is really useful because it allows you to see what the slope actually is. When you write slope-intercept, y equals mx plus b, the numerical value in front of x, which is sometimes called a coefficient, is the actual slope of the 2 equations, or in this case, being that they're the same, the 2 equations. So because 2 is in front of x and we're multiplying 2 and x, 2 is the slope of this particular set of lines, and they both have that slope. Another distinction is, in order for 2 lines that have the same slope to be parallel, the y-intercepts also do have to be different as well. If they were the same, then the lines would actually be the same thing and therefore would not be parallel. Sometimes we call that coinciding, by the way. If you have 2 lines that are written in different forms that end up being the exact same line, it might look like they are parallel in terms of their form, but in reality they might be the same line. Here these lines are actually different, but they have the same slopes, so they are parallel. So in this case, we want to identify the slope of a line that's parallel to one that already has a slope of 1/6. And right away, we can know exactly what that is. The slope we're looking for has to be 1/6. The reason why it has to be 1/6 is it has to have the exact same slope. There are 2 pieces of information I want you to draw from. Number 1, first of all, they have to be parallel. And if they're parallel, they have to have the same slope. Now, if in fact they're parallel and they happen to have a slope 2, then the slope that you're looking for is going to be 2. It's that easy. So remember that if you're looking for a line that has parallel to one that already has a given slope, you need to have the same slope that that line has. That is the distinction here. So if you take a moment to pause the video and see which response you think would best describe what's happening here, go ahead and do that now. As you can see, we are looking for what the slope of a line parallel to a line with a slope of -3 is. Look at the language that's being used. We want the slope of a line parallel to a line that has a slope of -3. This means that the slope that we're going to have for our line is also going to be -3. Of course, that means that the option that we should select is that the line is going to have a negative slope, just like the slope of the line given. The others have different slopes, positive slopes a slope of 0, or an undefined slope. Remember, a slope of 0 is often a horizontal line. A vertical line gives you an undefined slope. A negative slope is kind of the stairwell going down, and a stairwell going up is a positive slope. So visually that might be a difference that you can also reference as well. Now let's take a look at perpendicular. So if these equations are provided, what we should be able to notice from them is that we have opposite reciprocals. So if you look at the two slopes, we have -2 and we have 1/2. There also should be a little x here as well, so I'm going to draw that in. So here we have -2 and we have positive 1/2. When you have -2 as a slope, just keep in mind that it can be written as -2/1. These are opposite reciprocals of each other. If in fact we're opposite reciprocals, that guarantees they're going to be perpendicular. You must certainly recognize that right away. You can see on the graph visually why that's the case. Now the other thing that we should notice as well, because I just kind of touched on that, is the angle there. We can state that the intersection is at a 90-degree angle. That's what it should be for perpendicular lines. So visually we can see that on the graph, and that is another observation that you can make as well. So now taking a look at that exact same set of slopes, but this time what I want you to focus on is the fact that we're looking at perpendicular and we're looking at the given slopes, 1, 6, and 2. You can equally and just as quickly identify the slope that you need, because in this case we need the opposite reciprocal of 1/6, which is -6/1 or -6. And the opposite reciprocal of +2 is -1/2. Remember that if you have a slope of 2, it actually can be written as 2/1. So the opposite reciprocal of that is -1/2. So now you can identify with these two equations whether or not they're parallel or not, or perpendicular. In this case, we would say that they're parallel because they're both written in slope-intercept form and they both have the exact same slope. So as a result, they're parallel. Now what you should see here with these two, when you look at the two equations that we have on the left, we can see as well from the graph and those equations that they're definitely not parallel, and we can justify that because their slopes are different. So we can probably start off by mentioning that the slopes are different. The slopes are not the same, nor are they opposite reciprocals. That's another observation that you can make. So while they intersect, they do intersect, but not at a 90-degree angle. So by saying that they don't have opposite reciprocals for slopes, nor are the slopes the same, we're showing that this is a case where it's in fact neither of those, and this is what that would specifically look like in this case. So now we get to the last part of this really, which we're starting to get to the point where we're wanting to write equations and identify whether or not they're parallel, perpendicular, or neither. So we're already given equations in this particular problem here, and that's perfectly fine. There's nothing wrong with that. And we want to go ahead and identify, are these lines parallel, perpendicular, or neither? I strongly urge you to utilize the same form for both. Now, it's not just enough to put them in the same form, because we also prefer the slope-intercept form. The reason why we prefer that form here is because slope-intercept actually reveals the slope. So we want this form right here, y equals mx plus b. So in order to do that, we need to solve for y first, and we can take this equation at the bottom here, And we can write that up here at the top. We have 2y equal to 3x minus 12. And what we're going to go ahead and do is we're going to divide everything by 2 because we want to solve for y first. And when we divide that by 2, what we end up with is y equals 3 over 2x minus 6. This is important because now I can compare this slope with this slope. One way I can write my justification now is that negative 2/3, let me use my pen here, I'll use this color, times 3 over 2 is equal to negative 1. Or you could say they are opposite reciprocals. Because they are opposite reciprocals. This means they are perpendicular. Because we've shown that the slopes are opposite reciprocals, we now know that they are in fact perpendicular. Okay, so with that being said, maybe pause the video here, take a moment, and see if you can determine the relationship between these two particular equations. You should have said neither in this case. For this particular problem, I would have taken the second equation, which I will write now over here, 15x minus 3y equal to 9, and I would have written it in slope-intercept form. Starting off, I would have gone ahead and subtracted the 15x on both sides. Now, at that point, I recognize that there's nothing left on the left but negative 3y, and on the right, I cannot combine the 9 and 15x, but I can write them together as they are here, a negative 15x and a positive 9. Then I can divide everything by negative 3, so I can get y by itself. During this time, the goal I'm trying to achieve is that I'm putting both equations in the same form. So here I get 5x minus 3, and now I can compare the two slopes because they're in the same form. We have that negative 4 and that positive 5. So because they are not the same and they're not opposite reciprocals, it's neither in this particular instance. In the final couple examples, our task here is to practice writing an equation of a line that is parallel. So I want to single out that language. Parallel to y equals 2x minus 10. And we are identifying specifically that the slope provided is 2. So that tells me that my slope that I'm going to use is the same. I'm going to use 2. Now over here you can see that we have the point slope form. That's what this is. Okay, so I'm going to go ahead and use the point slope form, and I'm actually looking at my points. I have negative 2, and then I have 11 for y and for x. So this will be my x1 and this will be my y1 that I plug into my formula, and then my m is going to be 2. So I have y minus 11 equal to 2 times x minus negative 2. So in that particular case, I have y minus 11 equal to 2 times x plus 2, and that is now the point slope form. So this right here is one of the forms that you could have your answer in for your particular problem. However, what I also want you to recognize is that we can take the point slope form that we have and we can write it in a different form. Usually the form you write it in is the slope-intercept form. For example, before I do that, I recognize that I have 2 here that I can distribute to get 2x plus 4. And I can go ahead and add 11 to both sides after that. So now I get y is equal to 2x plus 15. This right here represents the slope-intercept form of our equation, and this is going to be the slope, of course, as you can see. And remember that this is the slope-intercept form that we're looking at, right? So that's slope-intercept form as opposed to point-slope form. Both equations are the same thing, but you might be required to write your answer in slope-intercept. So I strongly urge you to refer to this slide for your exit ticket in your case or in your problem. In the final problem, we have another example where we're going to, in this case, determine or identify a line perpendicular to one that's given to us. And here we actually have our point of -6 and then 0. So we're keeping that in mind as well. Unfortunately here, the equation that we're being given is not written in slope-intercept. So we need to take the equation, which is 3x plus 2y equal to -4, and we need to first go ahead and subtract 3x on both sides. Then what happens is we end up with a 2y equal to -3x minus 4, where then we can go ahead and divide by 2. So after dividing by 2, what we end up with is, in this case, if I break it up here and here, I get y is equal to -3 over 2x minus 2. So therefore the slope I need to use is not -3 over 2. As we can see, that is the slope, but remember we want it to be perpendicular. So drawing on that knowledge right there, that tells me that I need to use a slope of +2 over 3. So now that I have my point, my x1, y1, I can go ahead and find my point slope form first. So we have 2/3 and then we have x minus -6. So that's going to get me y minus 0 equals 2/3 times x plus 6. And this is my point slope form right here. That's one of the correct forms. And then of course we can take that and we can rewrite it in slope-intercept form. So I have y is equal to 2/3 x plus 12/3. Y minus 0 was just y. And then that's 2/3 x plus 4. And so that's going to be my slope-intercept form right there, as I mentioned before. Again, you can refer to this example as well for your exit ticket. So for your exit ticket, you have 3 questions again, and I kind of throughout referred to certain slides that you should refer to in order to help you out. For example, the bottom question goes really well with those last 2 questions. I would say that the question above goes really well with this example right here. I would refer to that. And then your final question there, the slope of a line is given and the slope of a line B is given, and we just want to know what's true about them. Okay, so in the previous examples we talked about cases where it's parallel or perpendicular or neither, so you're looking for whether they're the same, opposite, reciprocals, or neither of those as a tip. And that right there is going to represent lesson 4.02 for proving slope.